Today I'm going to talk about LeetCode question number 2, add two numbers. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that two numbers do not contain any leading zero, except the number 0 itself. So for example, we have this example here. So this is basically, the numbers are stored in reverse order. So this is 3, 4, 2 plus 5, 6, 4, which is equal to 807, and we return the answer, as a reverse order linked list. Okay, and it's actually good that the digits are stored in reverse order because it makes it easier to do arithmetic one by one. How? Well, it's easy when it's like 5 plus 7 and the result is a single digit itself. But what if we do like 6 plus 4 and the answer is 2 digits? Okay? So basically when we do like 342 plus 4, 6, 5, so we obviously know this is 7, okay? And this 6 plus 4 is 10, so we add the 0 here. But then we have a remainder that we need to take into account. So we do 6 plus 4, which is 10, and then we add the 0 to our new linked list, our result linked list, and then with the remainder 1, what we do is in the next portion of the linked list, not only do we add these linked list values from the two lists, but we also add the remainder, okay? So like here, we add the remainder, so it'll be 4, 5, 6, 7, and 8, okay? And yeah, that's why it's good it's in reversed order, because we can look at the next value, and we know that if we have a remainder from the previous elements in the linked list, then this can apply to the next values in the linked list. Okay? And then that's basically how we're going to go about it. So we have to keep track of our answer and any remainders. Okay? So if we have linked list nodes here, so it'll be basically L1 plus L2 plus the remainder. Okay, so this is our equation here when going through the list and adding the elements together to create our new linked list. What about in this case here? The linked lists are not even. They're not the same length, I mean. Okay? So what this basically translates to is 1, 2, 3, 4, 5, 6. So that's 7 nines. 1, 2, 3, 4, 5, 6, 7. And 4 nines added. Okay? So what is the answer here? So we have 8 here, then a remainder, 1. We need to keep track of this remainder. So 9, another remainder, 9, another remainder, okay? 9, another remainder. But at this point, if we're looking at our list, we already finished L2 here. So what do we do with the rest of the L1 portion? Well, we can't ignore it, okay? We can't ignore the rest of the sum. So what we're going to do is basically now the equation that I described up here, L1 plus L2 plus remainder, it's basically going to be L1 plus remainder, okay? So while L1 is not equal none, we keep adding the L1 element plus the remainder. So this would be 0 and 1 and then 0 and then 1 and 0. We're at the end of the linked list, but we still have a value in our remainder. Our remainder is non-zero. So what do? Just add this at the end here. Okay? And then, yeah, this is basically our answer. Okay, just in the reverse direction. Okay. So this is going to take linear time of O of n. I guess we could say O of max n m, where n is the length of the L1 and m is the length of L2. We're going to traverse the maximum of the list here. Okay, so this is linear time. And yeah, that's basically how we're going to go about it. We have to keep track of the remainder and append the result to our new linked list. Okay, so now to code up the solution. So first off, what I'm going to do is initialize my result linked list. So the list node, okay, and everything after this result, this is going to be initial item in the result linked list, and everything after is going to actually contain, you know, the number, the sum. Okay, so like result.next is basically going to contain like 708 or whatever. Okay, and then I'm going to have remainder. It's initially going to be 0. Okay, and what else do I need? No, that's pretty much it. Okay, so now I'm going to traverse through the list. So while L1 does not equal none and none, and L2 does not equal none, what I'm going to do is add L1.val plus L2.val plus the remainder, okay? And then what I'm going to do is update my remainder. So remainder is going to equal to, so when we do L1, add this up. So since each node in a linked list is going to contain at most 1 digit. Yeah, it's going to contain a single digit. So the maximum single digit we're going to get for both is 9. 9 plus 9 is 18. So our sum is going to be 2 digits every time. We're never going to get like a 3-digit sum. Now I'm saying that because to get a remainder, what I want to do is divide by 10. Okay? And why do I divide by 10? So let's say 18 is our res here, and divided by 10 is gonna be 1 basically. If we in Python it rounds down. So yeah, that's gonna be our remainder for next iteration. And how do we extract this 8? What we're gonna do is modulo 10, and res is gonna be equal to res modulo 10. Okay. Now, what do we do now? So we're gonna create a new node with res as the value of the node. Res node res, and then result dot next equals new node, and then result equal to result dot next. Okay, and then obviously L1 equals L1 dot next, and L2 is equal to L2 dot next. Okay, and yeah, so we got that case done. Okay, and now what if we need to handle a case where either L1 is bigger or L2 is bigger, and if L1 is bigger, then L2 is basically going to finish first and force us to exit out of this loop. But we're still not done adding the numbers yet. So what we're going to do now is, in case L1 is bigger, so while L1 does not equal none, what we're going to do is now basically the same thing as up here, whereas L is equal to L1 dot val plus remainder. Okay, and yeah. And then remainder is that, and then result is that, and then the result to our result linked list. And then finally, L1 equals L1 dot next. Okay. What if L1 is already none and L2 was the bigger one? So we're pretty much going to do the exact same thing up here, except with L2. Okay, cool. But what if after all this, we still have a remainder left? Okay, so for example, we have like two nodes, 9, 9, and let's say 99 and 9. Okay, so in our result variable, we're going to have 8. Okay, and then obviously L1 here is smaller, so we're going to exit out of this loop, but we're not done with L2 yet, so we're going to go through this loop. And our remainder obviously is going to be 1, so we append 0 to our result, and then since 9 plus 1 is 10, okay, append 0, and then 1 is our remainder. We still need to add 1 here, okay? So what we're going to do is, if remainder is not equal to 0, or actually greater than 0, what we're going to do is, oops, I forgot. No, that's right. Then basically create a new node with our remainder, and then result on next is new node, result on next, result on next. Okay, cool. So yeah, that's pretty much how we're going to go about it. Actually, I should probably make a... Okay, so that's while result traverses do our result array here, head is going to still remain at the front. And then finally, what we want to do, return result head dot next. Okay, because initially result head is going to just be a floating, or not a floating, but list node that's just going to point to the first value in our result. Okay, and yeah, just checking the code here. I think it looks good. Yeah, so I'm going to try compiling it. Oh, oops. That's not an object. Okay, cool. And now we're going to try with the other examples here. Okay, looks good. I'm going to submit. Alright, great. Thanks for watching.